Alright, so with exponential functions, you can use them, like I said, to talk about saving money, finding out how much a car would be worth after a certain time, that kind of thing. But there's three important equations that you need to know. Okay? This is one of them. This is the one you will use most of the time. Okay? Most of the time, just basic kind of problems. This is the kind of problem that you're going to need. And we're going to have to talk about what each one of the letters mean. This problem, or this situation, is a time that the problem will tell you that something is compounded, and normally it will say like monthly or quarterly or something like that. Okay? What that means is that when you put money in a bank, if your money is compounded, let's say monthly, at the end of each month, you're going to get a percentage of the amount of money that's in the bank. And it's a little bit better than just compounding one time a year. Okay? If it just says yearly, you can use that first equation. But when it says compounded, monthly, quarterly, pretty much anything but annually, this is the one that you're going to use. And it's a good one because you'll have more money than if it was yearly. Okay, this next equation is a different equation, and you use this equation if the problem says compounded continuously. As far as that equation is concerned, it's hard to use that equation mathematically as far as understanding what it means by compounded continuously, but that means you're always earning interest off of your money. And so this is the best kind of equation that you would use. If they ask you when you go to a bank, which way do you want to compound it? You want to compound it continuously. You're going to get more money. It might not be a lot more money, but it's going to be more. So, let's talk about what all the letters mean. Okay? A is amount after a certain time. So, we might want to know how much is going to be in my account after 5 years. A is the amount. Okay, or I might want to find out how much a car is worth after a certain amount of time. That's the amount it would be worth. That's the A. A is normally what you're finding on the problems you're going to be looking at today. P is your principal. And as we talked about before, this is your starting value. It's your original amount, your starting value, it's your y-intercept. If I put money into a bank, it's the amount of money I originally put in the bank. If I buy a car, it's the amount I originally paid for the car. Okay? T is the time. If I want to know how much it's worth after 5 years, T is 5. If I want to know about bacteria and I want to know how much bacteria is there after 10 days, T is 10. It just depends on the problem. Okay, R is your rate. Now, when the problem is given to you in a percentage, you have to divide by 100, or you have to move the decimal over 2 places to the left. So, if it tells me that my interest rate is 15%, it's already in a percentage form, then I'm going to move my decimal to the left and I'm going to get 0.15. So we'll see that as we work. N, and it looks like I don't have a lot of room here, but it's number of times per year. Sorry that's so little. When you talk about compounding monthly or compounding quarterly or compounding whatever, N is the number of times per year that you're going to do this. So if you compound it monthly, how many times per year is that going to be? 12, because there's 12 months. If you compound it quarterly, quarterly is 4 times a year. Because you think about quarters and there's 4 that make $1. Semi-annually, means 2 times a year. It's actually 6 months that separated it, but it's only 2 times a year. Okay? And then I didn't do annually. Annually is 1. But really with annually, you can use that first equation up there. You don't have to use the second one. E is a special number. E is something kind of like pi. You know, pi is 3.14 and it keeps going. E is kind of the same thing. Okay? We're going to estimate it to be 2.71, but it keeps going on forever. It's just a number that we're going to use. It's a number that helps us with exponential growth and decay, and it helps things increase and decrease really fast. So E is a number that you won't plug anything in there. You're just going to use the E on the calculator on Desmos whenever we use that particular situation. Now, what you need to know is that when you have E to a power, that as far as growth and decay, it's just a tad bit different than we did last week. We talked about growth and decay last week, and as long as the number in the parentheses was bigger than 1, it was growth, and that number was less than 1, it was decay. With e to the x and e to the negative x, if it's e to the x, it's going to be growth. It looks kind of like that. If it's e to the negative x, it's going to be decay, and it's going to be kind of like that. And the reason that this one is decay, even though it's different, is because the power is a negative. Alright, number 1 says the value of gold grows by 1.5% each year. If you buy a piece worth $162, how much will it be worth in 20 years? Okay, I don't see the word compounding, so I know I'm going to use that first equation. So I'm going to have P plus R to the T. Okay, and that means I need to fill in everything. Okay, so I need to figure out what P is, I need to figure out what R is, and I need to figure out what T is, because it wants to know how much it's going to be, and that's what A is. So A is what I'm looking for. Alright, the value of gold grows by 1.5% per year. That's your rate, because it's a percentage. But you either divide by 100 or move the decimal over 2 places. If I move the decimal over 2 places, I'm going to get 0.015. Dividing by 100 will work as well if you like that better. You buy a piece worth $162. That's the original starting value. That's how much it started off. How much will it be in 20 years? 20 is the T. And so now I just put that information where it goes. So I'm going to put 162, 1, okay. It grows. Because it grows, this is going to be a plus. If it said it decreased, I'd put a minus right there. Okay. And then 0.015, and then raised to the 20. So we get 218.19. We can leave it there, since it's talking about money. So after 20 years, that $162 is going to be worth $218. 1.5% is not a lot, and that's the reason it didn't go up a lot. Okay. All right, let's talk about this car. So you buy a car for $12,500 today. The value of the car depreciates at a rate of 5% per year. What will the car be worth in 10 years? Okay. First of all, I don't see the word compounding. Because I don't see compounding, I don't use those other 2 equations. Okay? When I see compounding, that's when I have to think about those other 2 equations. So, what's P? What's my starting value? The amount that I paid for the car. Okay, R is my rate. I see that it's 5%. I either need to divide by 100 or move the decimal over 2 places. So it's not 0.5, but 0.05. When you think about moving it 2 places, like the decimal's after the number, and so if I move it 1 and then another, that's why there's another 0 in front of that 5, if you're doing it that way. Okay, my t is how long I'm trying to figure it out for, and that's 10. Alright, so then putting in my equation, I'm going to have 12,500. 1, okay, here's the trick. It says depreciates. So that means we're going to put a minus instead of a plus. 0.05 raised to the 10. So 12,500, 1 minus 0.05 raised to the 10. And we get $7,484.21. Okay, so this one says we've got $5,000 that's invested in a savings account that's paying 7.85% interest compounded continuously. How much money will there be in the account after 12 years? Okay, right here I see these words compounded continuously. Because I see compounded continuously, that tells me that I have to use the Pert equation. Just make sure that R and T are both in the power. Okay? So then, I know that I'm investing $5,000. So P is 5,000. I can see my interest rate. Okay? Remember, move the decimal over 2 places to the left. Or divide by 100. So you get 0.0785. It wants to know how much is going to be there after 12 years, so I know that T is 12. And then I just put that information in where it goes. So I'm going to put 5,000 E 0.0785 times 12. And then that's what you would get like as far as the equation goes. Now, putting it into Desmos or whatever calculator you're going to use is fine. Just be careful about how you do that. You do just go to the ABC to get the E. Go back to raise it to the power. Make sure that both the percentage and, see like that, how that worked, it didn't put the time in the power. So what you have to do is you have to put a parenthesis for the power so that it will times the 12 in the power. If the 12 is not in the power, it won't give you the correct answer. Okay. What this tells me as far as what I got here, I got 12,825. It's money, so I'm going to round it to 3 places, and then 53 cents. Alright, for number 7, when we read the problem, the words that jump out at me are the compounded quarterly. So we're still depositing some money at a certain interest rate, and we want to know how much money is going to be there after a certain amount of years. But the fact that this is compounded quarterly, what that tells me is that I'm going to use that other equation that we haven't used yet. Most of the time, this equation will be given to you, so you don't need to memorize this one. But you do need to memorize what things go where in this equation. So P is still 4,000 because that's the amount that you start with. R is the 6%, but we've got to move the decimal over 2 places. So 0.06. T is still 5 years because that's how long the money's going to be there. The N is the new thing, and the problem says compounded quarterly. So quarterly is every 3 months, but that means that's 4 times a year, so N is 4. And then you just put it in the information just like you have done on the others. Be careful with the power. You will have to put, I think, parentheses in the power when we put it into Desmos. So you'll have 4,000. 1 plus 0.06 divided by 4 raised to, and again put that parentheses to make sure 4 times 5 is in the power. If you want to multiply 4 times 5 without putting the parentheses and put to the 20th power, absolutely you can do that, and you will get 5, 3, 8, 7.